Okay, I'm using this session to do a recording for Learning Unit 5 revision. Right, so I'm going to share my screen. I'm going to take you through a past year paper. All right, so Learning Unit 5 is a this is a typical kind of question that could be asked using a cross-tabulation table. So cross-tabulation table basically shows how two variables relate to each other, right? So for instance, in this example, what you have here is you're looking at gender, shown by the row variables, females and males, against laptop brands, okay? So HP, Lenovo, the laptop brands, and gender is with female and male. So in the first row and column, value of 110, and that's telling you 110 female for HP. Right? Okay, so even both is here. Sometimes it's good, sometimes it won't. If it's you need to create a total. So it's simply just the value of columns. So 110 plus 150, and then you just do the same thing when you're adding numbers across the columns. So for the total number of females will be 110, 60 plus 70, which gives you 240. And the grand everything in this table up is 400. Right? You need these two. First question. The question says, what is the probability? Here we're looking at question 1. What is the probability of a male respondent from the sample? So I'm going to let a female just for matching. So what I want to work with is the probability being a sample. And that is simply the total of males. Right? So it's the total number of males, which is here 60, but the grand total number that. Okay, so the probability of anything is basically the number of in our case, the number that's the vector. So how many cases do we have to use? We have a label, and that's 60 and okay. If also in this example, it's exactly 40, and then only to make 0, only to make 40. Is just more places. Okay. Question. Let's this probability random select a respondent field of HP. So you know what probability of being and I can use the sum here intersection and if you want this probability, still how many cases do we have where females and HP intersect divided by the grand total? So let's look at this. I had some network issues. I'm just gonna go back to the whiteboard. This is a recording. Wasn't meant to have a live session today, but I'm just using this time to do a recording of revision of Learning Unit 5. All right, so I am looking at a cross-tabulation table here, as I mentioned earlier, between gender and different brands of laptops. So we're looking at question 1.1.2 now. Okay, and the question is, what is the probability of randomly selecting a respondent who is female and prefers HP? So the numerator is basically how many females prefer HP, or in other words, where do they intersect? And that would be here. There's HP and females is in that row set 110. So it'll be 110 divided by the grand total. Okay, and that gives us a probability of 27.5%. Okay, now let's move on to 1.1.3. All right, so 1.1.3 is, what is the probability of selecting a male respondent given, this is an important word, right? Because this means it's a conditional probability. What's the probability of selecting a male? So I'm going to write like this, given the symbol for that is this vertical line, that the preferred brand is Lenovo. So I'm just going to write LEN, for short form for Lenovo. Now for this probability, you use your formula sheet. Okay. Now your formula sheet tells you that the probability of A given B is equal to the probability of A and B divided by the probability of B. So in our case, instead of A and B, we have M and Lenovo. So instead of writing A and B, we're going to write male and Lenovo. So the numerator is the probability of male intersection with Lenovo divided by probability of Lenovo. Okay, because here, this is now your B and this is your A. All right, so we're going to work these probabilities out. Clear this. Right, that is, the numerator is, well, we're looking at how many males intersect with Lenovo, and that is 50. Okay, so it's 50. So the numerator is 400. This whole value here is the numerator. The denominator is the probability of Lenovo, and that is, how many Lenovo laptops do we have in total? We have 110. Right, so it'll be 110 over 400. And if you punch this into your calculator, so you've got a fraction divided by a fraction, that will give you 50 over 110. I'm just going to write straight as a percent, which is 45.45%. All right. Okay. That's question 1.1.3. So remember what I said? Leave your answers as a percent. All right. Let's make some space for the next one. I'm actually going to clear some space on the board. So we've done 1.1.1. Let's use the space to do 1.1.4. 1.1.4. So here what we want is, what is the probability of selecting a respondent who is male, or, this word here is very important, or prefers HP. So we're asking, what is the probability of male, or, and the symbol for that is this upside down, well, it's a U kind of symbol, male or HP. All right, here we will use the addition rule, right? And that's in your formula sheet. So your formula sheet would have A and B instead, but I have M and HP. So all I'm going to do is I'm going to use the same formula, but instead of A and B, I'm going to write M and HP. So this becomes probability of male plus probability of HP minus probability of male and HP. All right. And we just need to substitute those probabilities, those values of those probabilities, and we'll get our answer. So that becomes, now the first part is probability of male, and we did that earlier, which is 1.1.1, that was 40%. So I'm going to write instead of fractions, right? Instead of writing the percent, I'm going to write the final answer of the percent. So this is 160 over 400. This is the probability of a male. Plus, now let's look at the probability of HP. Probability of HP is 150 over 400. Because there are 150 HP laptops in total. All right. Over 400. And then the last probability is this intersection of joint probability of male and HP. How many males use HP? There's 40 of them. So where they intersect, that's 40. So that'll be minus 40 over 400. And that is equal to 67.5%. Okay, that's 1.1.4. Okay, so far we've used the formulas in your formula sheet, which is the conditional probability formula, right? This, and we use the addition rule formula. Okay, please familiarize yourself with these equations. You don't need to memorize them. You just need to know when and how to apply them. Okay. All right. So there's some more questions on this table. Let's continue here. So the same table. The next question is, what is the probability of selecting a respondent who does not fall Lenovo? So this is a complement rule. We use the complement rule here. So remember, if you want the probability of not A, or write like that, or the opposite of A, that is 1 minus the probability of A. So instead of A in our case, we are dealing with Lenovo. So we want the probability of not using Lenovo, which is 1 minus the probability of using Lenovo. So that is equal to 1 minus, now this probability here, it's easy to work out. Just look at how many Lenovo laptops you have in total. 110 divided by the grand total. And that will give you a value of 72.5%. So we use the complement rule here. All right, that's 1.1.5. Right, now let's look at 1.2. Okay, but this deals with something different. Okay, it doesn't deal with the table above. A recent survey found that the probability that a student at a particular educational institution was born in South Africa is 80%. So I'm going to let the event SA be you're born in South Africa. That's what it means. All right? And so what they're telling us is that the probability of SA or being born in South Africa is 80%. 0.8. The survey found that the probability that a student at the institution is male, okay, and was born in South Africa. So in other words, the probability of a student being male, which we'll write as M, and being born in South Africa, so remember SA is the event you're born in South Africa, is 0.4. Okay. The question is, what is the probability that a student at the institution is male given that the student was born in South Africa? So we need to formulate this mathematically. So what they're asking us is, what is the probability that the student is male given? So the mathematical symbol for given is vertical line, that they're born in South Africa. That's what we need to figure out. And we did this conditional rule earlier, because we use the same formula to work on conditional probabilities, which is, remember, probability of male and being born in South Africa all over probability of being born in South Africa. And we have these probabilities. They're given to us. The value for the numerator is 0.4. The value for the denominator, probability of SA, is also given to us, 0.8. And if you walk this and convert it to a percent, the answer is 50%. That's question 1.2. Okay, all you did here was use the conditional probability formula here. Okay, so remember, a key word to look for is the word given. That's an indication that you need to use the conditional probability equation here. Now 1.3 says draw a Venn diagram to illustrate the union of two events A and B, where A and B are mutually exclusive. Mutually exclusive means they don't intersect. Okay, they can't occur together. So for instance, having a head and a tail on a coin on a single flip, you can't have that. It's either going to be heads or tail. So if I had to draw a Venn diagram for that, let me just make some space to do that. Okay, we'll start off with drawing the box. So your circles will go in the box. So you draw the box and then draw the circles. Now I have obviously have a bit of an edge here because I have this tool to draw perfect circles, but you don't have to do that. Okay, just in the exam, you're not going to obviously have this. So you do the best you can just drawing freehand, but it should look like a circle. It doesn't have to be a perfect circle. So because they're mutually exclusive, these circles do not intersect. They will be like that. They don't overlap each other at all. They will be separate because they're mutually exclusive. The question tells you they're mutually exclusive. Hence why they don't intersect. So this can be A, this will be B, the circle will be B. They don't intersect, and that'll indicate that they're mutually exclusive. And one more thing you need to mention here is that the remaining space in this diagram, right? That is the area outside the circles, okay, as well as what's in the circle. So everything here. So I'm just shading it. You don't have to shade it. Okay, I'm just going to give you an idea that this area here, everything is the sample space. Okay, you don't have to shade it. I'm just doing it so you have an indication of what I'm talking about. So just please note that. So what I'm going to do is I'm just going to write in here is the sample space. Okay, so you need to do it exactly like how I did it. You don't have to do the shading. Okay, just remember that. I just did that before to maybe help your understanding. If it didn't really improve your understanding, then don't worry about it. Okay, just ignore the green squigglies, but everything else that you see in this diagram, this is how you would answer that question. Okay, and that is question 1.3. Okay, so this is what I want to cover for probability. This is a question from a past exam. I hope this helps in your understanding, but please try and work through it on your own and work towards the answers that I have. If you get something different and you're still not sure how you're getting that answer, please contact me and I'll assist you. Okay, but you do need to try and do this on your own. Okay, and that's it from me. I'm going to stop the recording and sharing my screen now. I will make the recording available to you. All right, all the best, everyone. Chat soon.